Okie dokie. So, assuming that the Lab 2 was the same, is the same this semester as it was last semester, we're going to work through Lab 2, or at least do a little summary of, what we're doing here. So, right off the bat, they introduced new Excel commands. The first one being the $sign. So the $sign, what does it do? It basically locks a cell in place, so that when you type in a single formula that will be eventually dragged down, you want to keep one cell locked in within all the cells that you've dragged that formula through. Does that make sense? So to demonstrate, what they had first was they had you add 9 to 2, 1 to 4, 1 to 5, and so on. And this was what they called the wrong way, because that wasn't the intention. So you type in this formula, just A2 plus B2, hit enter, and then you would click and drag this corner down. But this was not the intention. They don't want you to add just the T with the add values here. They want you to add 9 to all 5 of these values here. So the idea is, if we want to add the same value, the same cell, to all 5 of these different cells, well, this is what the formula looks like. So we do A2 plus B $2. B2 is the location of the 9 that we want to lock in place. So to do so, we type in B $2. So that locks it in place. And you'll notice as I click through these other cells here, the first value, the T value, is changing, while B $2 remains the same. Pretty neat. All right, so that's pretty much it. $sign, lock something in place. Now the next function is product. So using product, looking up here, the goal with this product page, I guess, is to find the product of 4 through 8, then find the product of 5 through 8, then product of 6 through 8, 7 through 8, 8 through 8. So here in this column B, they have you type in those products individually. So the product of A2 through A6 is 4 through 8. Then separately, you don't drag down any formulas here. You just type in product of A3 through A6, product of A4 through A6, A5 through A6, A6 through A6. And so those are the single products. These are the values that we want. But then they have you test out a wrong formula, where you type in the product of, again, the first 5 numbers, or all 5 numbers there, hit enter, and then they have you drag this down. But that's incorrect, because as you click through these remaining cells here, you'll notice their formulas are going to then reference 5 through 9, and then 4 through 8, and then so on, right? So the correct formula to find the product of 4 through 8, 5 through 8, 6 through 8, and so on, well, the cell that's staying consistent the whole time is the 8. We want to lock that 8 in place. And so we do the product of A2 through A $6, so A $6, to lock the 8 in place. And now as we go through these formulas, you'll notice it's locking the 8 in place, but moving the A2, A3, A4, and so on along the way. So that's the idea. So we lock that 8 in place while we practice that product function. So the product function, finds the product between as many cells as we want. So the last Excel function is paste special. So paste special is a way to copy and paste information without losing the values that might have been produced by formulas. So like column D here, what they have you do is click on column D, click copy, so Control C or Command C, and they have you click on H and paste it. So I would do Control V as in Virginia, and when you paste it, right, so because column D was made up of formulas that were referencing cells that were 2 or 3 cells over, well, if you're applying that to H, 2 or 3 cells over might have zeros in the cell, so that's why these cells might be 0, right? So instead of just dealing with that, you hit this little drop down bar here, and you go down to paste values, and you click on values. and it pastes the actual values that were in column D. And so there's I'm having a weird time with like when you copy it and then paste it and then hit enter. I'm trying to like get rid of the this like rotating thing here. If someone could help me out with that, that'd be great. But it just like stays there. Anyway, another way they have you do it, just real quick, is you can click on D, and then you can do it all like right-clicking, hit copy, right-click on H, hit paste special like they say, and then click on values, hit OK, and you know that works too. So same idea. All right. That's pretty much it for the Excel functions. Let's get a good look at compound inflation introduction. So let's see, they talk about a little bit about nominal income, while the number converted to another year is their real income. They're basically saying like nominal income is like the income, say some person was earning in 1 year in the past, say like 1980, but then the real income would be like what their income is worth in today's dollars. So like when, you know, people say like in 1900 someone won the lottery for $1 million, that might be worth like $2 billion today or something. I don't know if the lottery existed back then, but you get the idea. So nominal versus real. An example, they say, suppose you have a weekly wage of $400 at the end of 2015, and you want to know how much that would be worth in 2018. And so to start, they give you the inflation rate in 2016, so 3%. So to go from 2015 to 2016 dollars, you take that 400 and you add it to 3% of what you earn, so 3% of 400. So that would give you like the amount of 2016 dollars that you actually earned in 2015, something like that. So then they say you can multiply 400 by some number to get the same answer. So instead of having to do like 400 plus 0.03 times 400, what's an easy way you can just calculate this same thing by doing 400 times something? Well, that something would be, well, if we have 1 400 plus 0.03 400ths, well, altogether we have 1.03 400ths. So that multiplier is 1.03. You might be able to see it upside down here, but that's pretty much it. So then they give us this chart to fill out for multiple years. So 2015 to 2018, like we were talking about, from starting with a value of $400, and using these different inflation rates, can we find the amount of money that $400 is equivalent to in 2018? I guess, I don't know. I'm bad at talking about money like this. So I've kind of transposed this chart here. We're going to get rid of that real quick. So starting with what they have, to calculate the 2016 dollar amount here, we're going to hit enter or equals, and we'll click on 400. So again, we're going to do like that 400 times 1.03, but we're going to do it kind of in a kind of creative way. So we're going to do C15, this cell here, just click on that cell, times 1 plus, so instead of doing 1.03, we're going to actually reference this cell. So 1 plus 3% is the same as 1.03. Close parentheses, hit enter, and what that's done is taken 400 and multiplied it by 1.03. Now, the reason I used formulas for this and clicked on different cells is because now we should be able to click and drag this corner down so that it references, this cell and multiplies it by 4%, then adds it to its cell 412. So in this cell here, 428, what it's done is 412 plus 412 times 4%. And then in this cell, it's taken the previous value, 428, and added it to 2% of 428 to get 437. So maybe a little confusing, but basically you're just like multiplying by 1.03, 1.04, 1.02, all the way down. So you can kind of see those values down here. So 437 being this last one, 437 being the last one. That's pretty much it. So using the inflation rates, we found that $400 in 2015 was worth the same as about $437 in 2018. So that's pretty much it. So the big lesson here is, like I mentioned a moment ago, to get to that 2018 value, really all we did from the start was take that 400 multiply by 1.03, then 1.04, then 1.02 to get, the final answer of like 437. And so what this is, what these three values are, it's the, inflation each year. But when you multiply them all together, it's giving you what's known as like a compound inflation value over a certain range of years, I guess. So we're going to deal with that in these next few tabs here. So getting on to medium wages. So with the wages, let's see if I can just like talk through what we're doing here and kind of simplify it. Yeah, let's open up Excel here. So I think when you get this data, it's just A through C, and then you have to type in D through F and then go on from there. Column D, they have you type 1 plus inflation. So to lay this out, you're given years, you're given weekly wages, you're given a CPI rate, which is the inflation rate. And then they have you type 1 plus inflation, compound inflation, and real weekly wages. So 1 plus inflation literally is 1 plus the inflation rate. You don't have to do anything else. You just do, C2 plus 1. And then you'll drag this all the way downtown. That's it. And then compound inflation. Compound inflation, again, was kind of what I was referencing when, I said multiply these three values together. So it's like years and years and years of inflation rates being multiplied together. So in this case, to find the compound inflation, we are multiplying all these interest rates. All these are inflation rates, right? From the year, 1980 all the way to 2016. So the way we do that is we use our product function and we start from the first rate all the way to D38. But we want to make sure to put the dollar sign on D38, so D $38, so that it locks in that last value. So that when you drag this formula down, in every single one of these, so eyes, look up here, I guess, look at the formulas. D38 is staying in place while the D3, D4, D5 is going to change. So that's the important piece. It's summing up, or it's finding the product of, the right cells each time, with D38 being the last one. Yeah. All right. So then, to find your real median weekly wages, well, if these were your nominal weekly wages, the idea is to take the nominal wages and multiply it by the compound inflation. And that's pretty much it. So you can see we're just doing this times this, B2 times E2. You hit enter, and then that's the same all the way down. And so what that's saying is basically $269 back then is equivalent to $889 in 2016. Same idea all the way down. So a dollar was worth way more back then, right? All right. I think that's pretty much it. And then they have you do a graph for nominal and real weekly wages. So just as a reminder, how we do that is click on A, or really for this, you could just highlight A and B. So click and hold on A, drag it across B, go to Insert, Scatter Plot. You'd click on this, and it would spit out this graph here. Likewise, for real median weekly wages, you still want the years on the x-axis. So you'll click on A. I would hold Control or Command or whatever the button is. Click on F while you're holding Control. So you highlight both A and F, then you insert a scatter plot like that. And that would produce this one here. So you can see the nominal weekly wages, even though they were going up, inflation was making the real amount of your wages go all over the place. So I think that was about it for median wages. Nothing too crazy there. They ask a bunch of questions. I don't know the context to answer all the I mean, you could tell where the sharp increases were. It's like by looking at these graphs here. That's not too crazy, but like thinking about differences between average quality of don't worry about. I'm not gonna go into that. I'm just gonna show you how to do the math. Sorry. All right. So median. All right, so we did. I was getting confused because it was median wages. Now it's median household income. So you go over to the household income situation, and let's just do this again. So I believe they give you these three columns again, and then they make you do the same exact thing. So 1 plus inflation, compound inflation, real median wages. It is the same exact process. So 1 plus inflation, that's your formula. Drag it all the way down. Compound inflation, it's the same product, D2 through $D$38. Hit enter, you drag this corner all the way down. And then real wages would be the nominal income times the compound inflation. So if you earn, say, an income of about $17.7 thousand a year in wages, that's the equivalent of earning almost $60,000 in today's money. That's pretty crazy. Okay, so then they make you create graphs the same exact way. So highlight A and B to create a scatter plot. So insert scatter plot, make this. Likewise, highlight A and then click Control, hold Control, click on F, and then insert scatter to create this graph here. So again, same idea. Let's see if there's any other important things with the household that I'm forgetting. I don't think so. I feel like I'm... Nah, yeah, that's all they have you do there. And then they go to comparison. Okay, so in comparison, let's just open this up again. Looking at comparison, I think they just give you these years and then maybe like these two columns here, just the titles of them. So real median weekly wages and then real median weekly... Wait. I don't think this should say weekly wages. I think it should say like income or something. I don't know. I might have typed something in wrong. Hold up. Maybe I did that a long time ago and didn't remember it, but I am catching it now. So real median household income. Yeah, okay. So let me just type that in. Household income. Just realizing that. Oh, anyway. So what they have you do, if you calculated your real median weekly wages just back here, in this column F on wage income data, right? You click on F, Control C to copy it, and you go over to comparison, click on B, and you hit Control V, and it's gonna look crazy until you hit this down bar, hit values, and it fixes it, right? So that's your weekly wages, and then you go over to household data. They also want the real median. Oh, that's probably why. I guess I labeled it wrong from the get-go. So real median household income. You know what? I probably copied it from this back in the day. Whew. All right. Anyway, so you hit this, Control C, you go to comparison, and then you click on column D and you hit Control V. Again, it's going to have an issue until you go to paste special, hit values, and it, paste those values. So then I think it references, like, it says something about if these are the weekly wages and these are the household incomes, then obviously like these are going to be much less than this until we multiply the weekly wages by 52 to make it so it's like you're not just measuring the weekly wages but the yearly wages, right? So all they have us do in this column, real median yearly wages, is looking at this cell here. You take the weekly wage and you multiply it by 52 because there's 52 weeks in 1 year. So then once we do that, I think you have to like drag this down probably to fill in the rest. That's pretty much it. And then I think they have you click on A, hold Control or Command, click on B, or sorry, wrong one. Let's redo that. Click on A, hold Control, click on C and D because they want you to create a single graph with the years and the real yearly wages with the real median household incomes. So yeah, that's pretty much it. And so you'll see the difference between the real median household incomes up here in orange and then yearly wages in blue. That's pretty much it. again, the realistic questions here. I don't know if I'm the person to answer those, but hopefully this is helping you get through the math stuff. Towards the end, they ask about constant inflation. Yeah, we'll just kind of freestyle it over here. All right, so I think they give you A through D, and then you'll notice this like alternating actual inflation, which we've dealt with already, versus an ideal inflation rate. They say something about people coming up with this ideal 2% inflation rate. Like that would be the ideal inflation rate each year. And so we're kind of like running these numbers and seeing how it compares to the real. And I think there's some questions about like, I can't talk money and inflation. I don't know anything about this. But like, would it be like for the best, or like what's the downside of it? I don't know. Let's just talk math. So they have you for the, it's color coordinated, right? So the yellow is actual each time and green is ideal. So they have you do the 1 plus for both actual and ideal. So the 1 plus, again, 1 plus the actual rates. Click that corner, drag it down, you know the deal. And then same deal with 1 plus ideal inflation. You're doing 1 plus the 2%, and then drag it all the way down. It's going to be 1.02. Excuse me. And then the compound inflation, same function. It's the product with, in this case, E2 all the way to $38. Make sure to do the $, and then click and drag that down. Same deal here. There's your formula. Hit enter. And then basically what this is measuring is not like income or wage, whatever. It's just talking about the value of $1. So $1 back in 1980 has inflated. I don't know if that's the word, but the value in 2016 with actual inflation was $3.31. So $1 back then is equivalent to $3.30 in 2016 with the actual inflation. And then value in 2016 ideal inflation is $2.08. You'll notice that this column is pretty much just this column, but it's rounded to 2 decimal places. So maybe for these last two, you could like highlight G and H. You hit Control C, and then maybe click on I, and then do Control V to paste those values. But then you make sure to actually hit values. And then if they're not already rounded to 2 decimal places, then you can highlight both these and go to maybe just do one. Where is it? Home. There we go. So if you highlight both I and J, you go to Format Cells, and go to Number Decimal Places 2. If we did 3, it would look like that. If we did 2, hit enter. Make sure they're rounded to 2 decimal places because it's a dollar and cents amount, so 2 decimals. I think that's it. And then they have you do a graph, right? So you click on year, and then they want actual versus ideal. So you'd hold Control, click on I and J, insert, scatter plot. Let me just make sure this is the right idea. Yeah, so I think it's the same. It's just stretched out. Yeah. All right, and then they have you, compare the actual versus ideal on there. I think that's about all I have here. Yeah, I think I'm going to call it there. I hope that helps. If you have any questions, please let me know. Alrighty. Bye-bye.